In this lecture video, we'll be talking about Webster's method of apportionment. Daniel Webster proposed his method at the same time as Adams in 1832, and his method was the one actually implemented. This was at the same time that Jefferson's method was ousted for giving New York too many seats. What's interesting is that after Webster's method was used for the 1842 apportionment, they went back to Hamilton's method because they started to notice that Webster's method and Hamilton's method often produce the same outcome. The unofficial rule became choose the number of seats in the House so that the apportionment is the same under either method. Webster's method is similar to Adams and Jefferson's method, where we're going to use a modified divisor, but instead of using a modified divisor that works with lower quotas or with upper quotas, we're going to choose a modified divisor that works with conventional rounding, rounding each modified quota to the nearest integer. Let's start by copying down each state's standard quota. Let's round each standard quota to the nearest integer using just conventional rounding and see what total we get. 32.92 will round up, 138.72 rounds up, 3.08 will round down, 41.82 rounds up, 13.7 will round up, and 19.76 will round up. This gives us a total number of seats, 251. We're so close, we're just one seat over. Our standard divisor is 50,000, and it gave us just barely too many seats by conventional rounding. If we want to bring the total down, we need to bring our divisor up. That is, we want to choose a modified divisor that's greater than our standard divisor by just enough to bring this down by one seat. Since we only need to come down a little bit, let's try a modified divisor of 50,100. Written in millions, this would be 0.0501 million. The modified quota now for each state can be found by taking their population and dividing it by the modified divisor. This gives us the following values: 32.85, 138.44, 3.07, 41.74, 13.67, and 19.72. Now let's use our conventional rounding and round each of these values to the nearest integer. 32.85 rounds up to 33, 138.44 rounds down to 138, 3.07 rounds down to 3, 41.74 will round up to 42, 13.67 rounds up to 14, and 19.72 rounds up to 20. Notice that state B came down from 139 to 138, and all other states' values stayed the same. This means we brought down our total seat count by 1 to a perfect 250 seats. So this modified divisor worked. So what do you think of the potential hangups of Webster's method? Of course, it's not the easiest to implement because it still could take a couple of tries to find a modified divisor that works. It also has the potential to violate the upper quota rule or the lower quota rule. While our previous methods just had the potential to violate one or the other, with this conventional rounding, Webster's method can actually give a state more than their upper quota. It can also give a state less than its lower quota. So there's definitely the potential for some issues. But for now, that concludes our conversation about Webster's method of apportionment.